Good evening, everybody.
Hi, good evening. Good evening.
So here I am.
Hello.
Okay, class. So right now I am here to provide you a brief description of coursework which we will be taking over for Etabs. So I am here to give you a brief description on Etabs as well as why to go for Etabs. First of all, at present, Etabs is its market's demands, right? So that is the first and foremost reason for why to go for Etabs. Back in the day, Staad was the software to go for, but now Etabs is replacing Staad, especially when it comes to multi-story buildings, multi-story structures. So that is the reason for Etabs. Now, why is this happening? There has to be some reason for why this is happening, why why designers are moving from Staad to Etabs when it comes to multi-story buildings. Because while talking about Staad is like a mothership, right? You can analyze anything on Staad. Staad is for all sorts of structure. When it comes to Etabs, from Etabs family, from CSI, we have a software called SAP 2000. That is just like Staad. You can analyze anything using SAP 2000. And Etabs is basically the multi-story building design module from SAP 2000. They take it out, they enhance it, and they launch it as Etabs. So let's start. First of all, what are the objectives? What is the objective and what are the prerequisites for this software? So first of all, the objective of the course is to make you understand the Etabs way of working. It's given to make you confident in modeling and analysis using Etabs. It's a 21-day course. So our aim is to make you very much comfortable with environment of Etabs. So you can model as well as you can, and you will use the various analytical options provided by Etabs. And prerequisite is, as always, when it comes to software, whoever wants to learn this software, they have to have knowledge of manual methods of structure analysis and design. If you don't know how to do it manually, no software can help you out, right? Because software gives, as I explained, when for the demo for Staad and all, that Etabs or Staad or any other software, they all work on the basis of garbage in, garbage out. Whatever you are feeding in your input, the accuracy, the quality, the efficiency of the output depends upon whatever you are feeding at input. If you are lacking in your input, there is going to be discrepancy in the output as well. So in order to find out whatever answer you are getting, to be sure that you are on the right track, you have to know how to analyze or how to proof check your Staad output, your Etabs output with these manual methods, and for analysis as well as for design. So this is must for you to have this knowledge beforehand. If it is not the case, then the right now Etabs, Staad, or any other software is not for you, because there is a difference between these software, the designing softwares and drafting softwares like AutoCAD. Anyone can learn AutoCAD. You don't have to have an engineering background, and it's very much established in India that in order to work on AutoCAD, you don't have to have engineering background, right? With enough experience, you can work on AutoCAD. Fine, you can be an AutoCAD draftsman. You cannot be a draftsman. For draftsman, you have to have a certificate from ITI. That makes you a proper draftsman. But you can be an AutoCAD draftsman without any engineering knowledge. But when it comes to designing software, you have to have first of all you have to be an engineer, and you have to be good at it. So now, what is Etabs? It's a computer-aided design software. That's fine, but what it is, how people at CSI define Etabs. So Etabs is a special purpose analysis and design program developed specifically for building systems. As I told you before, that it is developed specifically for building system. There is as I told you, that there is a software called SAP 2000. Etabs is beforehand. Etabs was a module for SAP 2000. They take it out, they enhance it, they add it to it, and they launch it as Etabs. And in one way or another, this software is around for last 30 years, right? It is older than, as far as I know, this is even before advent of Staad and all. So Etabs is not in the form of Etabs, but this software is here for last 30 years. It's sophisticated yet easy to use. If you are asking me, Staad is fine, but I prefer the interface of Etabs more than to Staad, right? Staad is fine. Staad is the first software I learned when I was going through my education and all. But when I came across Etabs, I find its interface much more appealing and easy to use rather than Staad. So okay, so it's sophisticated yet easy to use. Okay, then in Etabs, model definition is floor by floor, column by column, bay by bay, and wall by wall, instead of nondescript nodes and elements in general purpose programs. So this is how they are trying to differentiate their software from Staad. When it comes to Staad, when you are defining a model on Staad, the basic unit is a node. Those who have attended Staad part of this course, they know that in Staad there is a node, then there is a element which is called beam in Staad terminology, and that beam has nodes on each of its side, and then come plate. So this is how Staad works, but in Etabs it is not the case. The model definition is floor by floor, column by column, bay by bay, and wall by wall. So basically it's not depending on nodes and beams and things like that. So this is the difference. This makes structural definition simple, concise, and meaningful. Maybe that is the case. This makes structural definition simple, concise, and meaningful. Etabs can handle the largest and most complex building models, including a wide range of non-linear behaviors. So that is already established. That was said way too many times before, that this software Etabs, it is mainly targeted onto multi-story buildings. In most buildings, the dimensions of the members are large in relation to the bay width and story heights. Those dimensions have a significant effect on the stiffness of the frame. Etabs corrects for such effects in the formulation of a member stiffness, unlike most general purpose programs that work on centerline to centerline dimensions. Now, in order to define this particular point, you have to be aware of some other general purpose program, as it is saying here that general purpose program. Okay, so when right now we are talking about Staad and Etabs, so let's compare it with Staad. So yeah, in Staad, design is based on centerline to centerline dimension, but that is not the case in Etabs. But for a structural engineer, that hardly matters, but that is the point here. Etabs is a completely integrated system. This means that you can create only one model of the floor systems and the vertical and lateral framing systems to analyze and design the entire building. That is a point I can relate to, and as a by extension, you all can relate to, that Etabs is a completely integrated system. Everything is in Etabs. So, and when it comes to some other software, so the thing is that in order to after analysis and everything, if you want to go for design, in some cases you have to go for different module in the same software, but you have to so what is going to happen? The software is going to transfer your analysis, your model, your analysis results, and everything to the this another module like reinforced concrete designer module or steel designer module or bridge design module or things like that. So that this is the case, that it's a completely integrated system. But again, this software is just for multi-story buildings, right? So you can understand, but it's a completely integrated system, and it's a good thing when you have to deal with multi-story buildings only. Now, what Etabs can do, because there are so many softwares out there, and as I told you that right now in India, Etabs is in demand. So that is the first and foremost case. But what exactly it can do? So first of all, multi-story commercial, governmental, and healthcare facilities. So that means buildings buildings for any purpose, whether it's a residential, it's a commercial, it's some kind of institutional. Etabs can handle them all, and it can handle them well. Parking garages with circular and linear ramps. Okay, so parking garages nowadays, when it comes to, even for, if we are talking about commercial building, you all know that they have to have parking facilities. Same is the case with residential, same is the case with institutional buildings. So Etabs, and if, for example, there is just a parking garage, no building attached, there is just a parking garage, it's a building in its building structure in itself. So Etabs can do it very well. Staggered truss buildings, building with steel, concrete, composite, or joist floor framing. So nowadays, if you want to go high, if you want to raise your structure vertically upwards, so after a certain limit, you can't go high just by using concrete, right? Then you have to include steel as well. So now your structure is not just a steel structure or just RC structure. Now it's a composite structure, and that can take Etabs can take care of it very well. After talking about structures in general. Now flat and waffle slab concrete buildings. So that is again incorporated with Etabs. If you are going for flat slabs or waffle slab, it can be done. Buildings subjected to any number of vertical and lateral load cases and combinations, included automated wind and seismic loads. Okay, so I'm sure you all know that there are two. The loads can be the structural loads can be categorized in two categories, right? One is vertical loads or gravitational loads, gravity loads, and another is lateral loads. So vertical loads, they are acting in the direction of gravity. They are acting towards the ground. These are the vertical loads, which includes dead load of your structure, any imposed load on your structure, live load or occupancy load. If there is a load due to snow, rain, everything is part of vertical loads. When it comes to lateral loads, we have only two loads. One is wind loads, another is seismic loads. So when it comes to wind load and seismic load, Etabs has this, you can say it is available in other softwares as well, but Etabs can calculate them automatically on its own, depending upon what information you are providing. And you don't have to go through manual calculations in order to find out effect of these lateral loads. So this can facilitate by Etabs as well. So multi-story parking garage, staggered truss building, composite buildings, then flat and waffle slabs, and then lateral loads, automated lateral loads. Then comes analysis. So multiple response spectrum load cases with inbuilt input curves. So what is a response spectrum? So let me go for response spectrum a bit. What exactly is response spectrum is? Then when you are going for seismic analysis, again, the seismic analysis is divided into two categories. One is static analysis or pseudo-static analysis, what we call, and another is dynamic analysis. So pseudo-static analysis, it has it's easier and it has its limitations. But when we are talking about multi-story and really multi-story, like about 10 stories structures, you have to go for dynamic analysis. And in dynamic analysis, we have this response spectrum analysis. So that can be done by Etabs. Automated transfer of vertical loads on floor to beams and walls. So you are applying vertical loads, right? As I told you, every load other than wind load and seismic load, they are all vertical loads. So let's talk, and where these loads let's talk about live load first of all, right? Live load is what occupancy load is, and where it is going to be applied. It is going to be applied on the slab, right? It is going to be applied on the slab. Slab is what we are exactly. Slab is the part of the structure which is exposed to our use. So what is going to happen from this? The load, the occupancy load is going from slab. It is going to transfer on the peripheral beams, and from these beams it is going to be transferred to the columns, and this is how load mechanism works. And from columns it is going to transfer downwards up to your foundation, and from foundation it is going to be distributed on the ground below. So what Etabs is doing is when we are going for loading and all, you will come to know that you can apply these live loads or dead load due to slab and all directly onto the peripheral beams. So this automated transfer is available on Etabs. And if you are applying load onto slab and all, Etabs can automatically transfer these loads onto the peripheral beams. In the, how to explain it, like a prism, right? You all know how two-way slab load distribution or one-way slab load distribution takes place. So it can be done automatically by the software. Then we have facility for P delta analysis, or as I told you, with static or dynamic analysis, you can also include P delta analysis. What is P delta analysis? Anyone? P delta analysis, we will talk about it when we come to it. Then comes explicit panel zone deformation. So in Etabs, I'm not aware of this in any other software, but when in Etabs, they have this this additional approach to panel zone deformations. What is a panel zone? Panel zone is where beams and columns, they come and merge together, right? The joints, the monolithic beam column joint in RC, and in steel it's just joints. So that is what a panel zone is, where more than where two beams and a column, they are intersecting with each other. So there is going to be a panel zone, and these deformations are they are taken care of, because when we are let's talk about reinforced concrete frame structure. What is happening when on the site? What is happening is they are casting columns. Okay, they are casting columns up to a certain level. What is that level? Is they are casting columns up to the height when it is flush with soffit of the beams, and then they are going to start framing for the beams and slabs. So rest of the column, which is going to be where the joint is going to takes place, it is going, for example, the grade of concrete for the column is M35, but after a certain height, along with the beam soffit of the beam, at that point, what is going to happen? Now beam and slab, they are going to cast them monolithically, and in most of the cases, what we have a grade for grade for beams and slab. It is always lower than grade of concrete grade of column. So this panel zone, that is going to be casted with a lower grade of concrete, but in design you are not taking that in account while designing. So in either you have to do it manually, but in Etabs you have this facility to take this panel zone deformation into account in your design. Then construction sequence loading analysis. So as you are constructing, as you are going upwards, the dead load is going to be increased in sequence. So that is taken care of construction sequence loading analysis. Multiple linear and non-linear time history load cases in any direction. And lastly, foundation or support settlement. So these are the points in which Etabs excel. Then large displacement analysis, non-linear static pushover, building with base isolator and dampers. You're right. So if you guys are aware that in high-rise buildings, especially how to explain, like I have this particular building in my mind, Taipei 101. I have, it was on National Geographic back in, yeah, it's like on National Geographic or Discovery back in the day. So what does that building have? Because it's like 101, that means it's 101 story high. So how to keep that? So you can imagine the height of that structure. Now, in up to, if you are building a structure up to this height, what is going to happen? At the top, as you are moving upwards, there will be oscillation in the building due to wind, basically due to wind. So what? So that these oscillation, okay, you can design to resist these oscillations, but it's not psychologically and it's not very good for occupants to feel these oscillations. So how to dampen them? So in order to dampen these oscillations, what they do, they have provided with a pendulum-like structure in the very center, very core of the building. So that structure, this pendulum, it is moving inside this core, and it is making the overall structure stable. So it is like that. So you can do this using this software, given you get the opportunity to work on such structure. Then comes floor modeling with rigid and semi-rigid diaphragms. And lastly, automated vertical live load reductions. As you all aware that in high-rise structure, code allows us to reduction in live load. If you have a structure above certain height, you can reduce your actual live load by a certain percentage. So either you have to do it manually, or in case of Etabs, depending upon your structure's height and everything, it can be done automatically. Now, in this point, we have talked about integrated system. So what exactly it is? An integrated approach. Everything is integrated into one versatile analysis and design package with one Windows-based graphical user interface. No external modules are maintained. That's what I was talking about. No external modules are maintained, and no data is transferred between programs or modules it includes. So this is the case. Now what it includes, what does it include? So first of all, we have drafting module, in which you are going to create the geometry on which you have to work on. So that is what you are going to do in drafting module. Then comes seismic and wind load generation module. As I told you that in Etabs, you can it can generate lateral loads automatically depending upon what information you are feeding it to. So that is seismic and wind load generation module. Then gravity load distribution module, that's what I was talking about. Like it can distribute the gravity loads on the members depending upon their stiffness and depending upon what kind of distribution system you are going for. Finite element based linear, static and dynamic analysis module. When it comes to analysis, you can go for static analysis, linear static analysis or dynamic analysis. Then finite element based non-linear static analysis and dynamic analysis. There is you can go for linear or non-linear. Output display and report generation module, how you are going to read onto your answers. You have to have output, right? So output display and report generation module. This is for analysis. Then comes design. So steel frame design module, concrete frame design module, composite beam design module, steel joist design module, and lastly shear wall design module. So this is all integrated into this particular software. Now, at last, what do we have? Modeling features. So, okay, let's go through it. The model geometry is idealized as an assemblage of area, line, and point objects. Those objects are used to represent wall, floor, column, beams, etc. So the geometry in Etabs, it is idealized as an this group of areas, line and point objects. Instead, you have nodes, beams, and plates. Here we have point, line, and area. Those objects are used to represent, of course, those objects are used to represent when it comes to line is going to represent column or beam. Area is going to represent, if it's horizontal, it is going to represent floor or roof, or if it's vertical, it is going to represent wall. So this is how it is. So this is the very basic of its modeling, its geometry, right? Then the basic frame geometry is defined with reference to a simple three-dimensional grid system, X, Y, and Z. A simple three-dimensional grid system. So each element have its this ordinate system in this space, X, Y, and Z. With relatively simple modeling techniques, very complex framing situation can be maybe considered. So that is it. I mean, as I told you, that its interface is very approachable. It's very approachable. Then comes the building may be unsymmetrical and non-rectangular in plan. Of course, not every structure you are going to design, it is going to be perfectly symmetrical or rectangle or something like that, right? It can be of any shape. So when it's not when it's non-rectangular, unsymmetrical, what is going to happen? Torsional behavior of the floors and interstory compatibility of the floors are accurately reflected in the results. So Etabs it boasts that it can take care of torsional behavior better than any other software. Then semi-rigid floor diaphragms may be modeled to capture the effect of in-plane floor deformations, and that is right, because when it comes to diaphragms, creating a diaphragm is much more easier in Etabs than any other software I have used. That is for sure. So semi-rigid or rigid floor diaphragms may be modeled to capture the effects of in-plane floor deformations. It is also possible to model situations, model situations with multiple independent diaphragms at each level. So you can create more than one diaphragms. Okay. But it can be done in another softwares as well, but in Etabs it's relatively easy. The column, beam and brace elements may be non-prismatic, right? What is a prismatic member? If it's square or rectangular, or it's like that, if it has well-defined edges, then it's prismatic. But it may be non-prismatic, and they may have partial fixity at their end connections, right? They have partial fixity at their end connections, and that is very much the case when it comes to a reinforced concrete structure, because on designing a reinforced concrete frame structure, what is going to happen at the intersection of these elements, the joints, how you are going to consider, like for example, a beam coming out from a column. So that is a fixed beam, it's given, right? But how you are going to model when a beam is coming out of a beam? In reinforced concrete I am talking about. If a beam is coming out of a beam, so you have to assume that one beam is going to be primary beam and another beam is going to be secondary beam, right? So okay, that is the case now. But what is happening while casting? What is happening? because of monolithical casting, what is going to happen? There is going to be some amount of fixity there, right? So they may have partial fixity at their end connections. The effects of the finite dimensions of beams and columns on the stiffness of a frame system are included using and offsets that can be automatically calculated. So we have this option of and offset where we can model these joints exactly the way they are going to be in real life, the way they are going to be on the site. You can model these joints using these and offsets as real as possible. Then the floors and walls can be modeled as membrane elements with in-plane stiffness only. So if you are modeling them as membrane element, they have in-plane stiffness. So what exactly is a membrane element? Membrane element, just to understand it, if you are modeling your slab as a membrane element, what is going to happen? That whatever load is coming over to this slab, the slab is going to transfer this whole load on the peripheral beams. Or if it's a flat slab, then it's on a column. Flat slab cannot be modeled as a membrane. Sorry for that. So if you are modeling your slab as a membrane, what it is going to do, it is going to transfer all its load, whatever load is coming over to it, to the peripheral beams. It is not going to absorb any, it is the structure, the software is not going to use the stiffness, the actual stiffness of slab element in its analysis. It is going to transfer everything onto the peripheral beams. So this is how a membrane works. So there, it just comes with in-plane stiffness. Plate bending elements with out-of-plane stiffness only, or full shell type elements. So these you can design your slab or your floor. You have all these options in order to model your floor system. You can go for just for membrane, or you can go for plate, or you can go for full shell type elements, which combine both in plane and out of plane stiffness. So basically what is happening is, when like membrane, as I told you, membrane, the structure is not going to, the software is not going to take care of the element stiffness of the element, and all the external loads, they are going to be transferred onto the peripheral beams. As opposite of it is shell. In case of shell, what is going to happen? The stiffness of this element, this floor system or roof system, whatever you want to, however you want to define it, its stiffness is going to be considered. And because of that stiffness, loads coming over to this floor, they are going to be accommodated by this element itself. It is not just going to transfer. Some load is going to be transferred, but most of this load is going to be accommodated by the stiffness of the element. Then comes analysis features. So what do we have? Vertical uniform loads on the floor are automatically converted to span loads on adjoining beams, or point loads on adjacent columns. Okay. I have explained this particular point before more than one time. Then comes the program can automatically generate lateral wind and seismic load patterns to meet the requirements of various building codes. Okay. So you have to choose the relevant code, and then program is going to generate lateral wind and seismic loads by itself. Three-dimensional mode shapes and frequencies, model participation factor, direction factors, and participation mass percentages are evaluated using eigenvector or ridge vector analysis. So we have these two engines for dynamic analysis, eigenvector and ridge vector analysis. And if you want, you can include P delta effect as well, whether for static or for dynamic analysis. Static analysis for user specified vertical and lateral floor or story loads are possible. Okay. Then response spectrum analysis, linear time history analysis, non-linear time history analysis, and static non-linear analysis are possible. Now, response spectrum, linear time history, non-linear time, linear time history, they are all part of dynamic analysis. Then results from various static load conditions may be combined with each other or with the results from the dynamic response spectrum or time history analysis. It depends upon the user, but you can combine all these results and you can find the worst possible combination for your design. Then lastly, output may be viewed graphically, right? You can view it graphically on your model, how things are playing out, or it can be displayed in tabular output, sent to a printer, exported to a database file for further work, or saved in ASCII file. It's a file format. You can save it in that file format as well. So these are the options when it comes to output. So that is it for this brief description for Etabs. If you have any questions, please fire on.
हेलो हेलो सर. हाँ सर, मुझे एक डाउट था. इसमें क्या बीवीएस निकाल सकते हैं आरसीसी का?
बिल्कुल निकाल सकते हैं.
जैसे कि सर आप बीम का डेप्थ है 600 और अपने को रेनफोर्समेंट मेन बार और ये एक्स्ट्रा बार कैसे मालूम पड़ेगा कितना रहेगा इसमें?
कैसे मालूम पड़ेगा?
जैसे कि सर आप डेप्थ है बीम का 600 है और ये इसका विड्थ है 300.
ओके.
तो इसमें एनालिसिस का ऑप्शन होता है क्या कि कितना बार्स लगेंगे? जैसे कि बॉटम में.
सुनिए लिसन.
हाँ सर.
आप फर्स्ट ऑफ ऑल एनालिसिस और डिजाइन करेंगे तो यू आर गोइंग टू गेट एरिया ऑफ स्टील, राइट?
यस सर.
देन एरिया ऑफ स्टील, यू गेट एरिया ऑफ स्टील. नाउ इट्स योर चॉइस कि आप उस एरिया ऑफ स्टील को लेकर उसको मैनुअली करो, आगे आपका जो डिटेलिंग है. नहीं तो आपके पास ऑप्शन है इसमें, जैसा कि स्टैड में होता है, इसमें भी ऑप्शन है कि आप उस डिटेलिंग को ईटैब्स के थ्रू करो. ये ऑप्शन है, ऑफ कोर्स ये ऑप्शन है. ठीक है ना?
ओके सर, थैंक यू.
नो प्रॉब्लम. Anybody else? Any queries? Okay, so I hope. Any query? Ram?
Yes, sir.
Yeah, please go on.
Sir, I have doubt. Etabs, I know how to use Staad Pro. Etabs, you can do the steel design also. Steel design for
Yes,
PEP
you can do.
For example, in Staad Pro, we have to provide all the load for the node support, and wind load also. Some code is not available. For example, PS code something is not available. Only AAC code only is there. In Etabs, how to provide the wind load like other VS code and the AAC code.
Yeah. You are right. You are right about that. When it comes to Staad, if you want to generate wind loads, you have to go with ASCE code, right? Because IS code is yet not included in that. That is what you are referring to, right?
Yes, sir. Yes, sir.
Yeah, but when it comes to Etabs, they have included IS code as well.
Okay, automatically it generates, sir. We have to
Right.
provide your own data.
Right.
Okay.
Yeah, you have to do a little bit of work on your own, but yeah, that can be done. It's not like Staad. It's much more better than Staad when it comes to auto wind load generation.
Oh, okay, okay. Sir,
Okay.
we can do PEP also in Etabs, pre-engineering building,
Pardon?
pre-engineering building, tempered, tapered eye sections.
Yeah, pre-engineering building. Yeah, you can do it. I don't have personal experience for pre-engineering building, but yeah, it can be done.
Okay, 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 sir. Okay, thanks so much.
No problem. Anyone else? Okay, I hope to see you all in our regular classes from 26th onwards. If there are no more queries, so let's conclude this demo. Good night all.
Good night, sir.